Welcome back. Ever wonder where your data actually goes when you hit save? Or how these massive tech empires run globally without, well, just completely crashing? Today, we are bringing you a comprehensive explainer on the invisible technology that literally runs our modern world. Okay, let's dive into this, the definitive guide to cloud computing.
Here is a quick roadmap for our explainer today. First, what is the cloud? Second, how does the cloud actually work? Third, deployment models. Fourth, the pros and cons. Fifth, top providers and uses. And finally, number 6, careers and the future.
All right, Section 1. What is cloud computing? The basics.
So, at its absolute core, cloud computing is simply the delivery of computing services over the internet. Whether you need servers, massive storage, databases, or software, the cloud's got you covered. There's an old joke in ID that the cloud is really just someone else's computer, and honestly, that is completely true. Instead of buying and maintaining your own clunky physical hardware, you're just renting access to a provider's setup.
Think of it exactly like electricity. When you want to turn on the lights in your living room, you don't go out and build a massive, expensive power plant in your backyard, right? No, you simply plug your house into the grid, and you pay only for the watts you actually use. Cloud computing works the exact same way, just, for technology.
Moving on to Section 2, how the cloud works, history and mechanics.
Now, this technology didn't just magically appear overnight. The core idea actually started way back in the 1960s when computing was first proposed as a public utility. The modern era kicked off in 1999 with Salesforce, followed pretty quickly by Google Docs and Microsoft Azure. Fast forward to the 2020s, and the cloud has completely transformed into our global digital backbone.
Physically speaking, the mechanics are surprisingly straightforward. Step 1, you, the user, access these services through a simple web browser or app over the internet. Step 2, your data zips over to remote servers located in massive, highly secure data centers. Step 3, the cloud provider takes on the massive headache of managing all that physical hardware and security for you. And Step 4, you just pay for the resources you consume. It's on-demand, self-service computing at its absolute finest.
Next up, Section 3, Deployment and Service Models, Flavors of the Cloud.
First up, let's look at deployment models. A public cloud is owned and operated by a third-party provider. Think Google or Amazon. It's cheap, it's incredibly scalable, and it's fantastic for startups. But you do trade off a tiny bit of control over your data environment. On the flip side, a private cloud is infrastructure used exclusively by one single organization. It's highly secure and gives you full control, making it absolutely perfect for banks, but it's significantly more expensive. Basically, think of the public cloud like riding the bus and the private cloud like owning your own armored car.
But hey, you don't always have to choose just one. A lot of large enterprises use what's called a hybrid cloud, which combines public and private environments so data and apps can just move seamlessly between them. It's cost-effective and secure. There's also the multi-cloud approach. This is where a company might use AWS for their storage, Azure for their AI, and Google for analytics, all at the same time. It maximizes flexibility and keeps them from getting locked in to just one vendor.
Now, it's absolutely crucial to unpack the big 3 service models. Think of this as the rule of 3 for the cloud. At the base level is IaaS, or Infrastructure as a Service. You rent the raw IT infrastructure, like Amazon's EC2 virtual servers, but you still manage the operating systems and the apps yourself. Step up one level to PaaS, Platform as a Service, and the provider handles the OS too, letting developers just focus entirely on writing code, like on Heroku. Finally, SaaS, Software as a Service. The provider manages absolutely everything. Think of everyday apps you use like Gmail or Netflix.
All right, Section 4, the pros and cons, benefits and drawbacks.
Let's start with the massive benefits. The cost savings here are huge, mainly because there are literally zero upfront hardware costs, and it totally reduces the need for giant internal IT teams. Plus, you get incredible speed and agility. You can deploy new applications in minutes instead of months. You also get global reach, meaning you can push apps to data centers worldwide instantly for low latency. And let's not forget advanced security, automatic backups with 99.99% uptime guarantees, and the absolute magic of instant scalability. If your website goes viral overnight, the cloud instantly scales your resources to handle that massive traffic spike without crashing.
However, to be objective, we do need to look at the disadvantages too. The biggest one, internet dependency. Simply put, if your internet is down, you have zero access to your tools or your data.
There are also third-party security concerns, simply because your data is physically sitting on someone else's servers. Also, those pay-as-you-go costs, they can sneak up on you and turn into surprisingly high ongoing monthly bills if you aren't careful. Finally, you do have limited control over the underlying infrastructure, complex data compliance laws to navigate, and the rare but very real risk of provider downtime. Meaning, if AWS goes down, well, half the internet goes down with it.
Moving right along, Section 5, Top Providers and Uses, Market Leader.
Now, what's really interesting about this slide is the sheer dominance of one single company. Amazon Web Services controls roughly 32% of the entire global market. They were early to the game and have the largest suite of services by far. Right behind them is Microsoft Azure at 23%, which is an absolute powerhouse in enterprise environments. Then comes Google Cloud at 12%, known heavily for their AI, machine learning, and big data tools. Rounding out the top, we've got Alibaba Cloud dominating the Asia-Pacific region at 4% and IBM Cloud at 3%, heavily focused on hybrid enterprise solutions.
So how does this actually impact our everyday lives? Well, in healthcare, it enables instant telemedicine. In banking, it runs real-time fraud detection. Education relies completely on it for virtual classrooms. Streaming giants like Netflix are entirely built on cloud platforms. And honestly, if you've ever played a modern multiplayer video game without a ton of lag, you have cloud computing to thank for it.
Finally, Section 6, Careers and the Future. What's next?
Because businesses are practically entirely reliant on the cloud today, the professionals who build and maintain these systems are in exceptionally high demand. Just look at these average salaries. A cloud architect averages around $140,000 a year. Cloud security engineers pull in roughly $130,000, and DevOps engineers sit comfortably at about $120,000. Data engineers and cloud developers are regularly seeing salaries well over the six-figure mark too. It is absolutely a booming field.
If you want to break into this space, the absolute best path forward is through specialized certifications rather than just a traditional degree. The heavy hitters listed here are exactly what employers are looking for right now. The AWS Certified Solutions Architect is pretty much the gold standard. For Microsoft environments, you want the Azure Administrator, which is known as the AZ-104. There's also the Google Professional Cloud Architect, the CompTIA Cloud Plus for a great vendor-neutral foundation, and the CCSP for anyone specializing heavily in cloud security.
So, where is all this heading? The future horizon is pretty wild. We are seeing AI built directly into the platforms. There's edge computing, which means processing data right at the source to completely eliminate lag. Security is shifting rapidly to zero trust, basically never trust, always verify. We're moving towards fully serverless environments, and maybe the wildest frontier of all, quantum cloud, delivering mind-bending quantum computing power as a totally rentable service.
As we look at these incredible advancements, it leaves us with a pretty massive question. With AI, edge processing, and quantum technologies rapidly integrating into these global networks, how will the cloud fundamentally change the limits of our digital lives next? Definitely something to think about. Thank you so much for joining me to decode the cloud today. Keep learning, and I'll catch you in the next explainer.